Hi, my name is Nick Borson, and this is the sixth in a series of videos about learning to program using PowerShell. These videos are aimed at non-programmers who want to learn how to code. We're using PowerShell as our first programming language. And the videos kind of build on each other, so if you haven't already, you might want to go back and start at the beginning of the series. There's a link to the playlist in the description. So in this video, we're going to talk about arrays and loops. And let's go ahead and get started. So here I have a terminal window open with PowerShell, and I'm going to start by talking about arrays. So let's first change into the directory. I'm going to type cd to change directory into the directory where I'm keeping my PowerShell scripts. And now let's talk about arrays. So what is an array? An array is simply an object that contains a sequence of other objects. So maybe I need to back up a little bit and talk about what is this word object. An object is just a term for a piece of memory in your a piece of data in your computer's memory, and it could be something very simple like an integer, or something a little more complicated. Like in the last couple of videos, we worked with datetime objects, and a datetime object has a bunch of different properties like month, day, year, and so on. So integer and datetime are two different types of objects. Object has a type that determines what it represents and what sort of operations you can perform on it, what properties it has, and so on. But all of these, regardless of the type, are just different kinds of objects. So an array is an object that contains other objects, and the objects are in a sequence, and you can refer to the individual members of the array or elements of the array by their position, by their numeric position in the array, starting at 0 and counting upward. So let's go ahead and create an array. I'm just going to call it, let's say we have an array that just contains first some even numbers. So I'm going to call it evens. I'm going to assign it to a variable. So I'm going to say evens equals. And one way you can create an array is simply to type a series of expressions separated by commas. Okay, so now we look at the variable evens, and we see when we type that and it gets formatted for the screen, each of the elements of the array just gets written on its own line. So we have 2, 4, 6, 8, 10. So what is the type of evens? So let's type evens get type. Just like you can with any object, you can call get type on it and get the name of the type. And we see that it says evens is an object, and then we have these square brackets. The square brackets mean that this is an array, and specifically it's an array of object. Why array of object? Well, because it's an array that can hold any kind of object. We aren't really being picky about what kind of objects we can store in the array. It can hold any kind of object, and so it's an array of objects. We can say evens dot length, and it tells us the number of elements in the array. So we have 2, 4, 6, 8, 10. There are 5 elements in the array. Or we can say evens count, and it gives us the same thing. Those are kind of interchangeable. Array has length and count properties that mean the same thing. Both of them mean the number of elements in the array. What if we want to refer to particular values in the array? Well, like I said, they're based on position. So the first element in the array has position 0. We always count up from 0. And so the first element, we use the square brackets. Just like the type has square brackets in the name, we use the square brackets to refer to members of the array. Evens 1 is the second element, the element at position 1, counting up from 0, 4. And evens 4, for example, is 10. Now evens has 5 elements, but the last, because we're starting at 0 in our numbering, the indices of those elements are 0, 1, 2, 3, and 4. There is no evens 5. Okay, so if we type that, we just get nothing back. If we say, what is that thing? What is the value of evens 5? It's equal to null. Okay, so that's what PowerShell does. If you refer to something outside the bounds of the array, it just gives you nothing back. It gives you a null value back. Now, there are other languages that might crash your program or do something else in that case. PowerShell tends to be kind of forgiving, so it just handles this case by giving you a null back, giving nothing back. Okay, so that's one example of an array. There are other kinds of arrays. That one way of creating an array is simply to separate values by commas, and you get an array. What if you have only one value? So let's say I said evens equals 2. Okay, well now, if I say evens get type dot name, it's an int 32 because it's just an integer. It's not an array of integers. If I wanted to have just one value, but I wanted to actually make it an array, one way to do that would be to put a comma in front. Evens equals comma 2. And now if I say evens get type dot name, get type dot name, then it is an array of objects, and evens dot length is going to be 1 in this case. So you can put the comma in front. Another way you can do it, that's a bit more, that I prefer, it's a bit more explicit, is to use this notation. You can use an @ sign, left parenthesis, and then list the elements of the array inside. So evens 2. Okay. Now again, evens get type is going to be an array of objects, and it has, I can say evens 0 is going to be 2. And that's another way of creating an array. One nice thing about that notation is I can actually create an array of 0 elements. The array still exists, it just doesn't have any elements. Evens equals @ and then is empty. And again, it has an array. It is an array, but it has a length of 0. Okay. Why would you want to do that? Well, you can start with we can start with an empty array and then add two arrays together, and you get a bigger array. So I could say, so here we have evens as an empty array, and then if I say evens equals evens plus 4, now evens, that didn't do what I expected. Oh, well. All right, let's say evens. Oh yeah, it is. It is what I expected. We started with an empty array, and now we have an array. Evens.length is equal to 1. Evens.getType.name. It is an array of objects. And likewise, I can say evens equals evens plus 6. Right. So we can adding a value to an array gives us a new array with the new value added. And just an array is actually not, you can change the values in an array. So I can say evens 0. So currently evens 0 is 4, right? But I can actually assign, I could put this on the left hand side of an assignment and store 2 in there. And now evens contains the values 2 and 6. So I can modify the values in the array. I can't actually change the size of an array. All I can do, because an array is fixed in size, all I can do is create a new array that has additional values. So for example, if I say a equals evens, so this is the original array. A is now, a and evens are now the same array. And I say evens equals evens plus, and let's add another array to it that contains the values 10 and 12. Now evens has 2, 6, 10, and 12, but A is still the original array. So we didn't actually modify A in place. We actually just, in this addition, we took the original array, we added another array, and we got back a new array. Evens now refers to this new array that contains 4 values. And the original array we had, A now still refers to the original array we had that only has 2 values in it. Okay, so those are arrays. So one way of creating an array is to actually list the individual elements of the array as we did here, either just using the commas between them or by using this @ parenthesis notation, and you can add arrays together to get bigger arrays, or add individual items to an array to get a new array that contains those additional items. Another way you can get an array is anytime you have a command that outputs more than one item, then the result of that command is going to be an array. So let's just actually write a little mini function right here in the terminal window, and I'll just call it get colors. Okay, I don't need a parameter list because this doesn't take any parameters, so I'm just going to go right to an opening brace, and I'm just going to type red, green, blue, and then closing curly brace. Okay, so we've just written a very simple function. All it does is it has 3 statements. Each of the statements is simply a literal string, and so the effect of those statements when you evaluate this first statement, it's just going to output that string to the, it's going to write that string to the output of the function, and likewise for green and blue. So what if I type get colors now? Okay, it outputs red, green, and blue. What if I assign get the result of that to a variable? So I'm going to say colors equals get colors. And what is the type of colors? Colors, colors, get type. Oops, got caps locked on. And it is also an array of object. And I can say colors dot length, and it does indeed has 3 elements. And I can say colors 0 to refer to the first color in the array, and colors 2 to refer to the last element in the array. So lots of functions return multiple items, and so in fact let's take a look at a built-in function. Let's look at what's in the current directory. We'll just type ls for listing the files in the current directory, or I can type dir to do the same thing. So if you've ever used a command prompt on Unix-like systems, you've probably typed ls. On Windows, on the old Windows command prompt going all the way back to MS-DOS, essentially the same command is called dir for directory. It just gives you a list of files and subdirectories under the current directory. Both of these in PowerShell are aliases. So just to make it convenient and short to type when you're just interacting with PowerShell, a lot of these commands have shorter names that may be more familiar and are just quicker to type. But both of these are aliases for a PowerShell command called getChildItem. So if I type get help ls, then it actually gives me help for a PowerShell command called getChildItem, because ls is just an alias for getChildItem. Okay, so I'll clear the screen here. Let's type ls. Let's type ls again, or getChildItem. Okay, gives us the same thing. And if I'm just typing at a PowerShell prompt, I'll tend to type ls because it's just quicker to type. But if I'm writing a script, I will tend to use the longer name because a script is something that is going to last for a while, and you might come back and look at it again, and using the more formal descriptive names can make the script easier to understand. Okay, so what is all these PowerShell commands, they actually return, they have an output that you can assign to a variable, and that output is an object. So if I take by the way, this current directory contains a subdirectory called VS Code, and it also contains these 3 script files we've created. What if I just want the files and not the subdirectory? Well, I can type ls-files. I got that wrong. File, not with this. And then I just get the files and no subdirectory. So there's another variation. So what if I want to just assign the result of that to a variable? Files equals ls, or if I want to be more formal, getChildItem file. Okay, now I've assigned the output of that command to a variable. And although the output looks like this when it's written to the screen, it looks like this text right here, sort of a table. The output of the command is not just that text, it's actually an object, and that object is an array. It's just that when we output it to the console, it gets formatted in a way that makes it easy for us to read. But in fact, this files, the output of the function, is an object, and we can get its type, and it is in fact an array of objects. Now, each of the elements of the array is an object in its own right. So we can say files 0. Okay, and it's also an object. and we can get its type. The type of that object, files 0 get type dot name, and it's called, this is an object of file info. So the array is just an array of objects, so it could hold any kind of object, but it happens that this particular array is holding 3 file info objects. So let's find out more about these file info objects. Just to make for convenience, I'll just create a variable called file, and I'll assign the first file to this. We'll just call it F to make it really short. F equals files 0. Okay, and let's see what properties this has. I can type. So if I just type F by itself, it formats it in this tabular sort of format. What if I want to make it? If I want to see more properties, I can type F pipe format list. So formatting it as a list instead of as a table. And when I format it as a list, it gives me more properties than when I format it as a table. Because when I format it as a table, it wants to make it so that you can actually, it doesn't use too many columns. So it only shows some of the what it thinks are the most important properties for that type. When I format it as a list, it gives me a few more properties. So we have a name, a length, a creation time, a last write time, and so on. And I can refer to the individual properties using the dot notation. So assign f.name is firstscript.ps1. When I use format list, I can actually specify what properties I want. By default, it shows some of the more common properties. It depends on the type what properties it shows you. I can say property, and let's say I just want to show the name and the length. Notice I've separated these by comma. Comma. This is actually an array. I'm passing an array of property names as the argument to the properties, to the property argument or switch, the property argument. So anyway, it gives us back just the name and the length. What if I want to show all the properties? I can type property star, and this is actually quite helpful because maybe I want to see what properties I have for this object. It shows us more properties than we got originally. See, for example, it has a base name, so that's the name minus the extension. So here's an extension, is .ps1. The name is firstscript.ps1. If we take off the extension, what we have is just the base name. There's also a directory name. The file is in this directory. And there's a full name that is the directory name plus the name. So if I want to be able to be in any place, I could go to the root directory of my storage device, and I want to be able to refer to this file no matter where I am and be able to access it. I can use its full name, and then it's not it's not just going to look in the current directory. It's going to look in this exact location. So it's very helpful to know the full name of a file sometimes. Okay, so anyway, the point here is that the get child item command returned an array, just like all these other commands. Just like we can create an array by enumerating items, A equals 1, 2, 3. We can also create an array by having a command that outputs more than one thing, and those things are then represented as an array. An array is an object. It has a length or count. You can use those property names interchangeably, and you can refer to the elements of the array using the subscript operator, and we always start at 0 to refer to the element at the beginning, and 1, 2, 3, and 4 to refer to the elements after that. So that's arrays. Let's then go on and talk a bit about loops. Okay, the rest of this video is going to talk about loops. I started with arrays because I wanted to have something to loop over. But what are loops? Well, loops are a kind of flow control in your program that allows you to do something more than once. Flow control, we talked in the previous couple of videos, we used if and else if and else statements. Those are examples of flow control. Specifically, there are different kinds of branching, and looping is another kind of flow control. There's different kinds of loops as well as there are different kinds of branches. So to illustrate this, it might help to visualize it in a certain way. You can imagine your program as kind of a path that has forks in the road, if you will, and branch statements are are ways of describing forks in the road, different routes that the program, that your computer can take as it follows along the path you've laid out. So this is kind of reviewing a little bit, but let's say we have a program that has some statements. I'm just going to label them A, just not anything specific, just A, B, etc. And then we have an if. So this is an example of a branch, and I'm not going to specify what the condition is, but there's going to be some sort of Boolean expression here that the ... stands for. And then we have curly braces, and then we do C and D, say, if that condition is true. Then we have an else if, and we have another conditional statement here. And if the if condition was not true, then we skip over the C and D and we go down to, and then we evaluate the else if condition. And if that's true, then we'll do E and F, say. And if neither the if nor the else if was true, then we might have an else statement, or an else block rather, and then we'll do G, or what have you. And then at the very end, we'll fall down to and do whatever comes after. And then we have additional statements that come after the whole thing. So let's use a different color here. Let's illustrate that in a more visual way. So let's imagine we have this. Your program is the computer is walking down this path that's our program, and each statement is like a signpost on the path. So it's going to do A, and that's going to do B, and then it comes to a decision point. So this is our if. Okay, and it's going to evaluate this this expression, this Boolean expression, which is either true or false. And if it's true, it's going to continue into the body of the block of code that corresponds to the if statement. So it's going to do, so this would be true. It's going to do C and D. But if it's false, it's going to take a different path. This is sort of a fork in the road here. That's why it's called a branch statement. Then we have our else if. Right? And if our else if is true, then it's going to do E and F. This is sort of the block of code. This block of code here corresponds to this path, this branch in the path here. And if the else if condition is false, this is true. If the else if condition is false, then it's going to go to the else block, which has G, right? So this corresponds to this. So this is the else. So this is where the else. So if the else if is false, and then at the very end we have these paths kind of converge again, and we come down to here, and here's we have H. Okay, so our flow kind of starts at the top. Normally things just go from top to bottom, but then every time we have an if or an else, one of these flow control statements, then we're going to make a decision, and we have a fork in the road. So here we have. If the if is true, we'll go down here and then continue on to H. If the if is false, but the else if is true, we're going to continue on to here and then move on to H. And if the if is false and the else if is also false, then we're going to go to the else block and execute G. And in all these cases, we're going to fall through to H. So we're going to take one of these three paths, depending on that. So that's examples of flow control in a program, specifically branching. So what about looping? Well, all these cases we're kind of going in a downward direction, right? We're just advancing through the program, and we might take different branches, but we're always going to continue on in a forward direction. But what if we decide that we want to do something more than once? Maybe at this point, instead of, we're going to go right back up here again and repeat what we did before. And we might do that a certain number of times. There's a decision point here. Do we want to do it again or not? And at the end, we'll continue on to the end. So a loop can go back, and then it can continue on. It can go back and continue on. And then at some point, we decide, okay, we're done. And so it's called a loop because it's like, if you think of it like a path, like a road or something, it's something as a series of the block of code that's controlled by the loop is something you might execute 0 or more times, and each time you might be doing some variation on it, right? You might be operating on a different thing, different piece of data, or a different number, or something like that. Okay, so that's kind of the concept of loops, but what does that actually mean in practice? Well, here we have our PowerShell prompt, the same one that we were working with arrays on here. It's going to go to full screen here. So the first kind of loop we're going to talk about is a for each loop. So here we have our array that has just 3 numbers in it. So for each loop, we can just say for each. It's a keyword, for each. And then we have our parentheses. And we'll just say $n in $a. Okay, and then we have our curly braces, and I'm just going to type $n. Okay, what does this mean? So the for each is just telling us that this is a for each loop. Then we're always going to have this parentheses. Inside the parentheses, we have something in something. So on the left side here is our loop variable. Okay, we're defining this variable, and all that means is inside the body of inside the block of code that's controlled by the loop, that's inside these curly braces here, this variable is going to take on whatever value is the current item in the thing we're looping over. So on the right side of the in is some sort of collection of objects. So in this case, an array. There are other kinds of collections, but let's just work with arrays for now. So here we have an array of objects, and what's going to happen is for each element in that array, we're going to execute this block of code, and n is going to refer to that element. So in this case, the block of code, all it does is it outputs the value. So when we execute it, it's just going to write 1, 2, 3. We could change this a little bit. We can say current value is n. Okay, so now we have a string, and we have inside the string we refer to a variable, and so it's going to expand that variable to be going to replace our $n with the current value of that variable. And so then when we run our code, we execute this block of code multiple times, once for each value in the array, and we simply, in this case, executing the code simply means that that we're writing the string to the output. Okay, so there's the for each loop. It's a fairly simple loop as long as you have arrays to work on. You simply want to do the same thing to every element of the array, then you can use a for each loop. Now earlier we were using get child item to get a list of files. So get child item, and we want just the files, not the directories, right? So we did this before. Let's assign that to a variable as well. We already did this, but let's just do it again. Files equals get child item file. So let's write a for each loop that operates on our files. So we'll say for each, and again we have parentheses. We're going to choose a loop variable. Now each item in this array is a file info object that refers to a file. So let's just pick a name that's a little more descriptive. I'm going to call it file in files. So files is the array of file info objects that we got from the get child item command. And now we have the beginning of our block of code. That's the body of the loop. And within that body of the loop, let's just refer to a property of the file. So a file info object, one of its properties is the full name, right? We discovered before that a file info object has a full name. So let's just write the full name. So now, again, the body of the loop executed 3 times because there are 3 files in that array. And within the body of the loop, we simply output the full name. But we can do other things too. One of the properties of a file is its length. So files 0.length. We see the length here on the length column, right? This is actually the size of the file, the number of bytes in the file. So what if we want to do something? What if we want to compute the total size of all the files in this directory by just adding up all the lengths? Well, we can do that. One way to do it would just be to say we'll initialize a variable before we enter the loop, call it total equals 0, and then we're going to execute the, let's just do the same sort of thing here for each file in files, but this time, instead of outputting anything, we're going to say total plus equals file.length. Okay. Now nothing was output because we didn't write anything to the output. We simply added the length within for each iteration of the loop. So iteration is just another word for repeating something, right? And when you iterate, you're doing something repeatedly, and so iterating is sort of another word for looping, and each time you do it, that's one iteration. So in this case, this loop we're looping over 3 files, so there are 3 iterations of the loop. Each iteration, we're executing the body of the loop, and what we're doing is we're adding the length of the current file to the total length. And at the end of all this, total now is equal to 1,222, which is the sum of these 3 numbers. Okay, so that's the for each loop. We can of course do. We're not limited to having one statement, and they don't all have to be on one line. I could say for each file in files, and then I'm going to hit new line here. I'm going to say I want to say the name of the file. So if I say file.name, that's not going to do exactly what I want, because it's going to replace just this part, the variable name, with the name of the file. But I want to actually refer just to the name property. So I'm going to put this whole thing in $ parenthesis like this. So this means that this expression is going to be evaluated, and whatever the result of that expression is going to replace this in the string. Okay? So the $ parentheses means that the thing inside of it is an expression that will be replaced with the value of the expression, with the result of the expression in the string. So has length, and then I'm going to again have an expression, file.length. Okay, and then I'm going to say total plus equals file.length. Okay, and that's actually not going to do I forgot to reset total to 0, so now total is going to be 2,444. But anyway, you get the idea. So inside the loop body, we had 2 statements. The first statement output something wrote something to the output, and the second statement added the length to the total. Okay. So there's the for each loop. And by the way, we can actually use the for each loop as an expression. So let's say we want to just get the names, the base. Let's get the base names. Okay. I can write for each file in files, and I can say file.base name. Remember, the base name of a file info is the name minus the extension. Okay, so I've actually assigned, so here we've executed this loop again once for each file. There are 3 files, so we iterate 3 times. Each iteration we execute the loop body, and inside the loop body, the file variable now refers to the current file for that iteration. So we execute it for this file, then for this file, then for this file, and then in this particular case, what we're doing is we're simply this statement is simply an expression that evaluates to the base name of the file. So it just writes that base name to the output. Now, when you write something to the output, it becomes the output of the command, of the statement. In this case, so we've written 3 things to the output, and this whole thing now is an expression. We've written 3 strings, 3 names to the output, and so we now should have written, the result of all that should be an array that contains those 3 things. So if we type base names, then we have an array of 3 strings, and I can refer to individual elements of the array like so. Base base names. And I can get the length of the array. And I can even loop over that array. I can say for each name in base names, name is name. Okay? So there's the for each loop. Now another way you can do this in PowerShell is you can use the for each object commandlet. So we have our files again. Oh, by the way, one more thing I should say is that before I get to that, in our loop, the thing to the right of the in keyword, so inside the for each loop, inside the parentheses, we have something in something. The thing on the left is always just going to be a variable, and that takes on the value of each object in the thing on the right. That thing on the right, in all the examples I've shown so far, the thing on the right was also a variable that referred to an array, but it can actually be any expression that evaluates to some sort of collection that we can iterate over. So instead of saying, let me just back up here, do the for each file in, but instead of saying in a variable name, I'm just going to type get child item file. So I'm going to type a command, and I'll say file.length. Okay, so now instead of referring to this array, instead of looping over the array that we created earlier and assigned to a variable, we're actually going to invoke this command. When we enter the loop, we're going to invoke the command. That command returns an array of file objects. We've never assigned that array to a variable. We're just going to use it directly. Okay, and then for each item in that unnamed array, we're going to execute the body of the loop where file takes on that particular element. So this is where it's helpful to understand the difference between an object and a variable. We never created a variable for this array. It just exists unnamed on the fly. But for each item in that, but we did in fact create an array by invoking this command. And the result of that command is an array of 3 files. And we iterate once for each of those 3 files, and we can then refer to the length. So we can do the same thing now by using the for each object commandlet. So it's the same thing, but it's just expressed a little differently. So I'm going to type get child item again. I'll type file. Instead of putting it inside a for each statement using the for each keyword, I'm going to use the pipe operator. Again, this is this vertical bar symbol that is on most keyboards. It's right above the enter key. So it's like shift /. So that vertical bar symbol is the pipe operator. What that means is I'm going to take the output of the command on the left, I'm going to pipe it as the input to the command on the right. And the command I'm going to use on the right is for each object. For each object, its argument is a script block, so inside curly braces. And inside that script block, I can have whatever code I want. And in that code, this code then will execute once for each element of, so the output of this command is an array, and once for each element of the array, the for each object command will execute this block of code. So this block of code could then be, I can't say, unlike the for each loop where I chose a variable name here. Here the variable is given to me, and it's a special name, $_ which is called the pipeline variable. And I can say its length. Okay. So this is really the same thing as this. It's just here we're using this for each syntax, and here we're piping the command through a for each object commandlet. And again, if we wanted to add up the total size of all the files, I can say total equals 0. And then I can say I can do the same command I did above there, get child item file, pipe it to the for each object. And then inside the script block for the for each object, I can say total plus equals length. And again, I'm using the pipeline variable. The pipeline variable takes on whichever file, whichever the value is for the current iteration of the loop. So we're looping once for each object in the array that was passed in, that was the output of the previous command, and then for each iteration, that current value is the $_ So we're going to add the length of that current value to the total, and after we've done that once for each file, then the value of total should be the sum of all those. Okay. There is actually, by the way, in the particular case where we just want to add up things like that, there is a command just for that, so we don't even have to do this. I can say get child item file for each object. Oh, actually, sorry, I don't want to do that. And then instead of writing for each object, I'm just going to use the measure object. So this is another command that you can pipe something to, and so the measure object will take whatever you're piping to it, and it will do some sort of computation on it, and it can give you a count, an average, a sum. It has to be something numeric. Now you have to be able to you have to specify what it is you're measuring. So in this case, we want to measure the length. So remember this is an array of file info. So I'm not going to measure the files themselves. I need to measure the length property of each file. So I'm going to access the length property. That's the thing I'm counting up. And what sort of measurement do I want? I want the sum. Okay. So and we can look at, there's lots of online help for all these things. But when we get that, we get the sum. So we have 3 files. So the result of this whole thing is an object that contains these properties. We have a count, we have a sum. We can get the average length if we want as well. Okay. So the average length of the files is 407 1/3. The sum of all the lengths of the files is, and likewise we can get the maximum. What's the biggest file? Okay. Biggest file is 431 bytes. The sum of all the files is 1,222, and so on. So that's the measure object, kind of handy. And if we just want to get the sum property without all the other stuff, by the way, we can assign this to a variable. So what is that thing? It's a generic measure info. So the measure object command is going to return this generic measure info object that has these properties: count, average, sum, etc. What if we just want to get the sum as just a number? Well, let's do our measure object sum. Wrap that whole thing in parentheses. Okay, so this whole expression is going to give us a measure info, a generic measure info object, and then we can refer to the sum property, and that's just going to be 1,222, right? Which I guess has converted it to a double precision floating point value. And if we wanted to, we could always say, if we wanted to treat that as an integer, we can say int sum. Okay. So that was a bit of a digression, but it shows the power of these pipeline variables. If you sort of learn a bunch of these PowerShell commandlets and learn how to string them together, you can do a lot of things very concisely without necessarily having to write a bunch of complicated loops yourself. But nevertheless, there are times when you want to write your own for each loop, and you can do a lot of things with it. Okay, I think that probably pretty much covers for each loops. All right, next I'm going to talk about another kind of loop. It's called a for loop. A for each loop iterates over the elements in a container, like a collection of some sort, like an array. A for loop is a bit more generic. It iterates in lots of different ways. And in order to do this, I'm going to, instead of working on the in the terminal window, I'm actually going to create a script here. So I'm going to invoke Visual Studio Code, and I'm just going to, I'm going to create a file called loops.ps1. So this is, there is no file currently called loops.ps1, so it's just going to create one. This command will create that file for me and open it in the editor. Okay, so let me start by just talking a little bit about the general form of a for loop. So I'm going to put just a comment at the top here. So for loop, the general form of a for loop is we have for, the for keyword, and then inside the parentheses we have three different expressions separated by semicolons. The first is, let's call it init for short. It's an initializer. Sets the initial condition for the loop. Then we have a condition, and then we have an increment. And then inside the parentheses, we have the body of the loop. This is the statements that executes for each iteration of the loop. So let me expand on that a bit more. So init is just sets the initial. So this is evaluated before entering the loop for the first time to set the initial state. Okay. Condition is evaluated before each iteration to determine whether to enter the loop body. Okay. So as long as this condition is true, we're going to enter the loop body. And then when we reach the end of the loop body, then we come back, and then the increment is evaluated after the loop body to set up for the next iteration. Okay. Increment is a comment. It's, we're calling it increment. It can do actually anything you want. It doesn't have to be necessarily just incrementing a number, but it's a common thing to increment a number. So let's give a specific example. This is let's just say we want to do something 10 times. So I'm going to say for, and then we have our init. So I'm just going to, in this case, I'm just going to initialize a variable. Let's call it I. I'm just going to initialize it to 0. I'm going to assign the numbers, take the number 0, store it in the variable I, and that's setting up the initial condition when we enter the when we first encounter the loop. Then we have a condition. So this is a Boolean expression, an expression that returns true or false. And let's just say I'm going to keep executing this loop as long as I is less than 10. So I'll say I'll use the less than operator, which is simply -LT, 10. Then we have the increment. This is after we execute the loop body. Then we come up and we make some change to set us up for the next iteration of the loop. In this case, I'm just going to add 1 to I. Now I can do this by saying I equals I plus 1. Or a shorter form of that is I plus equals 1. But actually, if we just want to add 1 to a variable, there's an even, because that's a common thing, there's an even shorter form, which is just I plus plus. That's the increment operator. Okay, then we have the body. And it can, in this case, I put it all in one line. It's more common to break it out into multiple lines. And the body can be any number of statements, right? Just like we had for the for each loop, it can be any number of statements. But in this case, I'm just going to say iteration I. Okay. So before we actually run this, let's try to think through what this is going to do. So we start by just the flow of control starts at the top of our script, and we don't have anything else coming before, so we're just going to reach the loop. We first evaluate the init, so we're just going to assign 0 to I. Then we evaluate the condition. is the variable I less than 10? Well, 0 is less than 10, so yes, that's true. Since that's true, we go ahead and enter the loop body, and we execute this statement, iteration 0. Once we reach the closing brace, the end of the loop body, then we jump up to the increment, and we evaluate the increment statement. In this case, we add 1 to I and store the result in I, so I is now 1. Started out as 0, now it's 1. Then we go back, and we again evaluate the condition. We're done with the init. That only happened once. Now we evaluate the condition. This happens before each iteration. We say, is I still less than 10? Well, yes, 1 is still less than 10, so we do this again. Then we add 1 again. We get 2. We keep doing that. Eventually, I becomes 9. Is 9 less than 10? Yes, it is. So we should output iteration 9. Increment it again, then become 10. Is 10 less than 10? No, it's not. So then we should fall down to here, and let's go ahead and say after the loop, after the loop, I'll just write after the loop, and I'll just write I, okay? And here I'll say before the loop, okay? There we go. So let's run this and see what we get. And let me just snap this over to the right side so we can see the terminal window next to the program. So first thing we executed was this statement that comes before the loop. So we just output before the loop. Then we wrote iteration 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. As long as I was less than 10, we keep entering the body of the loop. So when I was 9, we went and entered the body of the loop. Then we would have, after the iteration 9, then we would have incremented I again. Then this would have been false, right? Once I is 10, this becomes false. And so then we fall down to the next statement after the end of the loop body. So then we say after the loop. And at this point, I is 10, right? So this is no longer true. We can always assume that whatever the condition this is no longer true when we got down to here, unless we broke out of the loop in some other way. There is actually such a thing as a break statement that can break out of the loop in some other way. Okay, so that's a simple for loop. Let's consider using the for loop in some sort of to do something useful. Let's say we have an array of numbers and we want to find a particular number in that array, and we want to know what the index of that number is. So to start with, let's get an array let's actually create an array that we can work with. Let me just comment this out for now. So let's say, for example, I just want a series of numbers, we'll just do powers of, I want to do 2, 4, 8, 16, 32. There's a kind of a neat way we can do that. I'm going to say, first of all, if I say 0, I can use a range like this. Okay, this is a quick way of creating an array, right? A equals A10. So this actually returns this range operator, range expression, will give us an array containing all the numbers from 0 up to and including 10. So a.length contains 11 numbers because it contains 0 through 10. So what if I say 0 through 10, and then I pipe that through a for each object, and then for each of those numbers, I'm going to evaluate this expression. I'm going to say 1, shift left, and I use the pipeline variable. So the first time I do this, I'm going to say 1 shift left 0, and then I say 1 shift left 1 all the way up to 10. Now, what is this shift left thing? So I'll go into this a bit more on another video. This is an operator that works on that shifts a number left 1 bit. What does that mean? Well, computers use binary notation. They represent numbers as binary numbers rather than what we're more accustomed to is base 10. When we're working in base 10 numbers, it's very easy to multiply a number by 10 because all you have to do is shift all the digits left by one place. For example, if we have 1 and we want to multiply it by 10, we just add a 0 at the end. And now we've shifted all the digits left one place and put the 0 at the end, right, as a placeholder. And if we want to take 10, if we want to take 125 and we want to multiply that by 10, again, we just shift all the numbers left one place, and we've multiplied by 10. Add another 0, shift everything left one decimal place, and again, we've multiplied by 10. So that's shifting left. In a computer, instead of using base 10, computers use base 2. So shifting a number left one place is just a very simple and fast way of multiplying by 2. So shifting left by 2 places multiplies by 4. Shifting left by three places, each time you shift left one more place, you're multiplying by 2. So this is giving us, anyway, that's a bit of a digression, but this is a nice convenient way to give us a series of numbers to work with. So let's take this and paste it into our program, and we'll just call this powers. These are all powers of 2. I'm just going to call it that, assign it to an array, and then let's write the output. Okay. And then just let's run our program. Okay, so we have this array that contains this sequence of numbers, 1, 2, 4, 8, 16, blah, blah, blah. Okay, so I want to write a function now that will find the index of some particular number in that array. So here we have, let's say we want to find the index of the number 16. Well, we know the number 16, we have this array, we want to find the position starting at 0 of that number. So that in this case it would be 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So 16 is the number at position 4 in that array using 0-based indices. Okay, so let's do this. First, let's do this the simplest way we can, but we'll just call it get index, we'll call it get index. I'll call it get index slow because this is not the quickest way of doing it. And we'll take two variables, or two parameters, excuse me. One is the array we want to work on, and the other is the value we want to find. And I usually like to declare the types. Well, actually, I won't bother. Okay, so we're going to write a for loop, and we're just going to start at the beginning. And we're assuming, by the way, that this array is sorted, that each item is greater than or equal to the item before. Okay, so what we're going to do is we're just going to start at the beginning of the array, and we're going to search until we find a value that is, since we know the array is in ascending order, when we find a value that is greater than or equal to, if we find a value that's less than the value we're looking for, we know to keep looking. But if we find a value that's greater than or equal to the value we're looking for, then we should stop. Okay, so I'll say for I equals 0, starting at index 0, I lt, and this time we're gonna loop until we get to the end of the array. Array.length. And at the end we're going to return I. Okay. Now this is very similar to the loop we wrote before, except instead of a hard-coded number, we're going to loop until we get to the length up to, but not including the length of the array. So we're only going to keep going as long as I is less than the length. When I is equal to the length, we should stop. We should fall out of the loop. And that, again, is because we're using 0-based indices. The last element of the array is at position length -1. Right? The first element is at position 0. The last element is at length -1. The position equal to length is one past the last element. Okay, so we'll just say current, current equals array I. So this is the value at the current position in the array. We're assigning that to a variable just for convenience. So now, let's see. We're starting with small values. So if current is less than the value that we're looking for, then we should keep going. But if current is greater than or equal to the value we're looking for, then we're done. We should stop. So if current is greater than or equal to the value we're looking for, and then there's a statement called break that means we're going to break out. We're just going to break out of the current loop. Okay, so that means that we're going to skip over the rest of the body of the loop, and we're just going to go straight down here and to the next statement after the loop body ends. Okay, so this is another way. So one way you can follow the loop is if the condition expression returns false, and then we come down to here. But the other way is somewhere in the middle of the loop, we might determine, oh, it's time to we're done. We shouldn't do any more. We should just follow the loop, and then we'll end up down here. So this will give us the index at which we either found the value we were looking for, or we determined that the next value is greater than the value we're looking for, so we aren't going to find it, or we reach the end of the loop. So let's try this. So we have our array of numbers, and let's say the number we're looking for is n is, let's say we want to look for 16. So we're going to find 16 in powers. Let's say index of 16 in this array is, and then let's go ahead and invoke our function get index slow, and then we give it the array, and we give it and we can specify, we can either use positional, okay, so powers here, because of we specify these arguments in the same order that they're declared. So when we actually enter this function, whatever this expression is then bound to the array variable, the array parameter. Whatever this expression is bound to the value parameter. We can also be more explicit about it if we want to by actually declaring the parameter names. By specifying name parameter, we can say array is powers and value is n. Okay, so that's the other way we can do it. And sometimes if there are lots of parameters to a method, and some of them might be optional, then using named arguments sometimes is more clear or just more convenient. But if some functions only have one argument or two arguments, and maybe both are needed, and it might be more concise to just say to not use the name. So you can do either one in PowerShell. So okay, and then we'll output the result. So we're creating this array that contains these numbers. Excuse me. We're going to search for the number 16. This I just assigned it to a variable so we can refer to it. We actually call our function, assign the return value to a variable, and then we output the result. So we say the index of this number we're looking for in this array is going to be that. So let's run this and see what happens. So index of 16 in this array is 4, and that's what we expect. 0, 1, 2, 3, 4. What if we have a different number? Instead of 16, we want to look for 15. Okay, that's a bit different because 15 is not actually in the array, right? So what should it do? Well, let's run it. It's also 4. And this is actually a useful result because we're looking for the number 16 in the array. We didn't find 16, but we returned the index where 16 would be, or excuse me, we didn't find the number 15, but we returned the index of where the number 15 would be if it was in this array. And in fact, if we wanted to insert the number in sequence, we would insert it at position 4 if we wanted it to be, if we wanted to construct an array that had 15 inserted into that sequence, that's where we put it. So it's kind of useful to be able to do that. What if we actually say n is 2000? Well, that's greater than any number in the array, right? So now we're going to say index of 2000 is 11. So we have 10 elements in the array, 0, 1. So this is actually 1 past the end, because if we were going to insert this number into the array, we'd actually be inserting it 1 past the last element. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 11 would be the next position. That's where 2000 would be if it were in the array. And again, we can say 1024, and we should get 10 because that's actually where 1024 is. Maybe it would be helpful. Let's write another for loop actually, just to make the array a little easier to scan. Let's say for I equals 0, I lt powers.length I plus plus. Okay, and let's just show our array. Well, so what value is at each index? So n equals powers I, and we can say I n. Okay. Let's run our script again. So we wrote for each index. Now we can more conveniently see what number is at each index. So index 4 is 16, and we look index of 1024 is in fact 10. That's what we expect. Okay, let's look at that loop again. This is a pretty simple for loop. This shows us kind of the power of a for loop, because we have access both to the, if we used a for each loop for this, we wouldn't have the loop variable I. We'd only have the value, right? We want to have, if we want to have both the index and the value at that index, then we kind of have to use a for loop, because we have the loop variable is the index, and then the actual value at that index is something we can compute ourselves based on the index. Now, what if I wanted to? I could combine these two. What if I wanted to put this, instead of having a variable here, what if I wanted to put this directly in the string, like so? Right. Well, that's not going to do quite what I want. Just to demonstrate that, let's try that. Oops, that's not what I want. So what happened here? Well, powers was expanded, so it took the array and actually expanded that out into a string by actually separating with spaces, and then I was separately expanded, so we got powers, and we got the left bracket was just inserted literally, and the right bracket was inserted. So these were two different variables that had expanded. I want this whole thing to be treated as an expression. So there is a way to do that. I can write $ left parenthesis and then right parenthesis around the whole thing, and then everything, this whole thing inside the parentheses is evaluated as an expression, and the result of that is inserted in place of this whole thing. Okay, so now that's just simplifying what we wrote before. So here we're generating an array, first 10 powers of 2, or actually it's going to be the first 11 powers of 2. Right? Anyway, we'll just say generate array of powers of 2. Write the okay, so we generate the array, we write the array in a nice readable format, and then we find the index and write that to the output. Okay, so we've used a couple of for loops here. Let me do one more for loop here just to increase our our testing here. We can, actually I'll use a for each loop. So let's pick a few numbers that we want to find the index of. We'll say for each in, and then we'll have an array. And let's look for 0. Let's look for, let's put some numbers we want to look for. So 0 is, we're looking for 0. We should that's a number that's before anything in the sequence. Might be good to look for 1 because that's the first element of the sequence. So let's look for 8. Let's look for 7 because it's not in the sequence. Let's look for 8. Let's look for 16, 17. Let's try 512, 513, 1024, and 2000. Okay, so let's give us a reasonable collection of different things we want to look for. So we're going to search for each of those. So for each, we're picking various, this is sort of, let's test some different numbers basically. Okay, and I probably don't need the @ thing here, but I could just write it like this if you prefer that notation. You can put the @ parentheses if you want to be more explicit about this being an array, but I don't think we need it in this case. So find the index using our slow and simple method. The result. Okay. And we have indexes of 0 is 0, because if 0 were if there is no 0 in this array, but if it were there, it would be at index 0 because it would be inserted before the 1. Index of 1 is of course 0. Index of 7 is 3 because if we did have a 7, this is where it would go. Index of 8 is 3, index of 16 is 4, index of 17 is 5, because if we did have a 17, it would come after the 16 and before the 32, so it would be at index 5, and so on. So all these are correct. Okay, so we've used a for each loop to just iterate over a sequence of specific values. We've used a couple of different for loops to iterate over an array. In this one, we used a for loop to iterate over the array, and we also had a break statement to prematurely exit the loop once the condition was met, once we found what we were looking for. Okay, so this function, I called it getIndexSlow for a reason, because this is just simply searching from the beginning of the array to the end. Now, we're assuming that this array is sorted, that is, it's in ascending order. Now imagine you were looking in a dictionary or a phone book or something. Of course, do people still use dictionaries or phone books? Well, anyway, if you were looking in an actual printed dictionary and you wanted to find something in alphabetical order, and you look for a particular word, you wouldn't start at the beginning of the dictionary and page through it from A all the way up to whatever you were looking for. You would, if you're looking for a number that starts with M, you would go somewhere in the middle of the dictionary, and if the first page you looked at was a word that came after the word you were looking for, you would go earlier in the dictionary, and then if the page you were looking at then was a word that came before you were looking for, you'd go later in the dictionary. It's sort of what's called a divide and conquer kind of approach. It allows you to quickly narrow down to find the value you're looking for without having to look for every single one. So we can do the same thing in our program. So I'm going to write another function called getIndex, exact same parameters. And this is going to, so this function, let's put a little comment here, find the index of value in array using linear search. So searching linearly from the beginning to the end until we find what we're looking for. this is going to find the index of value in array using binary search. In other words, it's going to subdivide the array in half each time. It's going to start in the middle and then look to see if the value is if we found the value, or if it's less than what we're looking for, we can split the array in half and look just in the first half. And then if it's less than the middle value of that subarray, we can split it again. So each time we go through, we can divide the array in half and reduce by half the number of things we have to look at. So this is a common algorithm. It's not something you necessarily write every day yourself. There are functions in a lot of libraries that can do this for you, but it gives me an opportunity to demonstrate both the idea of an algorithm that you can use to solve a problem, and also a while loop. So a while loop is actually simpler than for loop. So a while loop has what for loop, remember, it had 3 parts. The while loop just has 1 part inside the parentheses, 1 expression, and it's just a Boolean expression. And all that happens is the body of the while loop executes as long as the condition inside the parentheses is true. Now what we're going to do for this is, remember, we're subdividing the array into, basically we're considering a range of possible values in the array. Initially it's the whole thing, right? And then each time we look at some element, we're going to split it in half and look at only only half of it. So to keep track of that, I'm just going to have 2 variables. One's going to be called min index, and initially that's 0, because the value we're looking for could be any value from 0 onwards, from index 0 onwards. And then lim index, and initially that's going to be array.length. So I didn't call it max index because I'm choosing to, there are different ways you can do this, but I'm choosing to make this 1 plus, the index of the last possible value plus 1. So it's the limit. It's not the maximum, it's 1 past the maximum. So that's the limit. So at any given time, we know that the index of the item we're looking at is going to be greater than or equal to min index and less than lim index. Okay? Now we're going to have a while loop, which looks like this. While, and we're going to say while the min index is less than the lim index. So if we reach the point where if each time we divide the array in half, if we get to the point where the min index is equal to the lim index, that means we've actually collapsed down to where there's no more items to search. So that's where we're going to follow the loop when that happens. That's one of the cases where we'll end the loop. Okay, and when that happens, we'll just return, at this point, min index and lim index will be the same. We'll just return min index, which should really be the same thing as lim index. Okay. So now we're considering a range of we're looking at values in the range. In fact, let's actually add a right host Okay, so we've narrowed the range to now the value we're going to look at the value somewhere in the middle of that range, because we wanted to be able to reduce the size of our search by half each time. So we're going to compute the index in the middle. We can do that by, I'll just call it current index equals, I'm just going to take the min index plus the lim index And then I'm going to divide by 2. And remember that we earlier we multiplied by 2 by shifting left 1. We can divide an integer by 2 by shifting right 1. The reason I'm doing that is if I were to divide by 2, then I might get a fractional value. In PowerShell, dividing by 2 is, like, for example, if I say 3 divided by 2, it's going to give us 1.5. But I actually want to always get an integer. And I always want to round down. If I do 3 shift right 1, that's dividing by 2 by shifting all the decimal places right by 1 place, or all the binary digits right by one position. It's dividing by 2, and it's always rounding down, and it's giving me an integer result. And I want an integer result because we're using it to index into an array. I don't want to find item 1.5 in the array. I want to find item 1 in the array. Okay, so that's a bit of a digression there, but so the current index is the min index plus the lim index divided by 2, rounding down. Now, this is going to give us the middle one because essentially it's the average of these two values, right? We take these two values, divide by 2, we get the average. And because we're rounding down, we know that this value is always going to be less than lim index. So for example, if the current range is 0 up to but not including 3, then 0 plus 3 divided by 2 is 1.5, but since we're just shifting right 1, it's actually 1. If the current range is, let's say, 3 to 4, then 3 plus 4 is 7, divided by 2 would be 3.5, but we're just going to get 3. So we're not going to get 4, we're going to get 3, because we're always rounding down. So we're never going to actually hit lim index. That's important because we don't want to be out of range in our array. So the current value then, let's call it current, is equal to array current index. So we pick the middle value. Okay, now there are 3 possibilities. The value we're looking for could be less than the current value, greater than the current value, or equal to the current value. So let's say, so we're going to have an if value less than current. So the value we're looking at is less than the current value. The value we're looking for is less than the current value. That means it must come before the current index. Okay, which means the limit index, lim index is equal to current index. Else, if the value we're looking for is greater than the current value, now notice here we're setting the limit index equal to current index. Here we're setting the min index equal to current index plus 1. Why the difference? Why is there a plus 1 here and there's not a minus 1 there? Well, it's because, remember, this range is sort of inclusive at the beginning and exclusive at the end. That's why I use square bracket and round bracket. So so the value can be equal, the index that we're looking for can be equal to min index, but it has to be less than lim index. So lim index is one past the lim index is one past the maximum index that we're looking for. Okay, and then finally the remaining case is that they're equal, and actually I'm just going to return current index. Okay, now this is actually a statement we haven't seen before, return. So break breaks out of a loop immediately, exits from a function immediately. So it's going to drop right out of the function all the way down to this curly brace here. And it's also going to, if we have a expression after the return, it's going to write this expression as the output of the function. Okay, and here we actually don't need this. We could just write min index, but I'm choosing to. We could just do that, it'd be the same thing, but I'm choosing to do that. All right, so comparing value with current at current index. So I'm adding these right host statements just so we can see the this in action. All right, so let's scroll down here, and now it's going to write a lot of output, so I'm just going to have one. So I'm going to say get index, because we have all these right hosts. I'm not going to do it for all these cases. Let's just do get index of 16. Array powers value 16. Okay, and let's see what that does. And I'm just going to comment these out. Okay, so we're going to output our array. We're going to get index of 16. Let's try this again. Okay, so how did that work? So when we first entered our loop, I'm going to snap this to the right so we can see the code here. Okay, so this is our array that we passed in, and we're searching for 16. So initially our current range was 0 up to but not including 11. So min index is 0, and lim index is the length of the array, 11, one past that 10. So we're comparing the value we're looking for with 32 at position 5. So this the current index in the middle of the range was 0 plus 11 over 2 is 5, which corresponds to the value of 32. So we're comparing 16 with 32. 16 is less than 32, so we know we're going to have to look in just the first half of the range, right, before position 5. So now we've narrowed our range to 0 up to but not including 5. So lim index is now 5. So now we're comparing 16 with the value 4 at position 2, because 2 was in the middle of this range. Okay, so index 2, the value is 4. Comparing 16 with 4, well, 16 is greater than 4, so we know the value we're looking for has to be after index 2. So next time around, the range is now from 3 up to but not including 5. So we're going to look at index 4, which is in the midpoint of that range. So 3 plus 5 is 8, divided by 2 is 4. And this time we compare 16 with 16, and of course they're the same. And so in that case, we return the current index. Okay, so let's try it with all the different values we looked at, but I'm going to take out these right hosts because it makes things rather verbose. And this time I'm going to take this away. We're going to call both get index, get index. Okay. Okay, and we'll write the index both ways. Okay, and we expect I and j to be the same. If they're not the same, then we have a problem. Okay, so the slow method is kind of useful here because we're pretty confident that this is correct. So we can, if the fast index is different than the slow index, then we have a problem. Okay, we can say right host error, indices are different. Now let's run our program again. And fortunately, it was the same in all these cases. Okay, so we've learned to use arrays. We can declare arrays in all sorts of different ways. One of them is to use an expression that produces more than one output. So here we have an expression that this is a range expression that gives us an array of integers from 0 up through 10. We pipe that to a for each object commandlet. So that's one way of doing a for each loop. In this case, the body, the code block that we pass to the commandlet executes once for each item in the array, which is this range of numbers. And we used the shift left operator to give us a number that's a power of 2, a 1 shifted left by 0 to 10 places. Since this block executes 11 times, once for each number in this range, the result of this whole expression is an array of 11 numbers. So powers is an array of 11 numbers. Then we use a for loop to iterate over the array, but we do it by, instead of using a for each loop where we would get where the controlling value variable, where the loop variable would be a value in the array, we're using a for loop, and the variable I is an index into the array. There's a position in the array, not a value in the array. Okay, so I is initially 0. We loop as long as I is less than the length, because the length is 1 past the last index. So we loop as long as I is less than the length. After each loop or iteration, we increment I, add 1 to I. And then in the body of the loop, we output the index, and we output this expression, the expression inside the $sign parentheses. We output this expression, which is accessing an element of the array at index I, the element of the powers array at index I, using this subscript operator, using the square bracket operator. So that's what gives us this output right here. Okay. Then we use a for each loop to just give us a bunch of numbers we wanted to test. Inside this body, we call a couple of different methods, and we output the result. Now the methods, we use 2 different methods of searching for a number in the array. The slow method used a for loop. So we're just going sequentially from the beginning to the end until we find the number, or or reach a point where the value we're looking for, where the number in the array is greater than the value we're looking for. So that demonstrated yet another use of a for loop. And then finally, we demonstrated an algorithm. This is a bit more advanced, but we demonstrated an algorithm, and we used a while loop. And inside the while loop, we used some conditional statements, if, and else. And the while loop was used to implement a very common algorithm called binary search, which allows us to find an item in a sorted array more quickly by subdividing the array in half each iteration of the loop until we narrow down and hone in on the item we're looking for. Okay, so that covers for each loops, for loops, and while loops. And we've also gotten a little bit more of a review of other flow control statements. There are if, and else. And also, we can break out of the loop. We can return from a function, or return from, and also we've done a bunch of playing around with arrays. So we covered a lot in this video. I hope it gives you some fodder to play around with your own experiments. And until next time, thanks for watching.